X cubed plus x minus 1, and is defined on the interval 0, 1. Show that h of x has a root on this interval. So first thing, we'll start by finding h of 0, and we'll find h of 0, which is equal to h of 0 is equal to, plugging in 0, we get minus 1, which is less than 0. And then we plug in h of 1. Plugging in h of 1, we're going to get, plugging in 1, we get 1 cubed plus 1, which is 2. 2 minus 1 is 1, which is greater than 0. So what that means, guys, this is a cubic function. All right, so what that means is a cubic function, and we're focusing on this interval. So we have some interval, right? This is all, well, let's do a better sketch. So this is the interval that we have, right? So this would be h of 0. H of 0 is minus 1, and this is h of 1. H of 1 is 1, right? So by IVT, there must exist some root that is between 0 and 1. That's all the IVT says. Because h of x is continuous, and h of 0 is negative 1, and h of 1 is 1, there must exist some root. This root right here, we can call it c, where c is an element of 0, 1. That's IVT. So let's write that down now. So let's conclude now. So since h of x is a continuous function on the interval, since h of x is a continuous function on the interval 0, 1, and h of 0 is less than, h of 0 is negative, and h of 1 is positive. Hence, by intermediate value theorem, h of x, let me not squinch it up like that. By intermediate value theorem, h of x has a root c. You can say it has a root c that lies on the interval 0, 1. So that's the intermediate value theorem. All right, nice and easy, solved. Let's continue with this question now. It says, use the iteration of xn plus 1, which is equal to xn squared plus 1, with estimate x1 being 0.7 to find the root of h correct to 2 decimal places. Let's tackle this easy question. It says, use the iteration of this formula to estimate the root correct to 2 decimal places. So we're going to say, using this iteration, x2 is equal to 1 over x1 squared. All right, I don't know why this keeps happening. All right, let's continue. Don't know why that keeps happening. So it's going to be 1 over x1 squared plus 1. That's going to be x2, which is equal to 1 over 0.7 squared plus 1. 1 over 0.7 squared plus 1, that is going to be equal to We need to work this out. 0.7 squared plus 1. And so we're getting 1 divided by that is 0.671. So this works out to be 0.671. Nice and easy, soft. So that's what we get, 0.671. All right, no issues. So it says use 2 iterations of the Newton-Raphson method with initial estimate x1 to approximate the root of the equation g of x being e to the 4x minus 3 minus 4 in the interval 1, 2. Give your answer correct to 3 decimal places. Now the key thing is that look what it said right here, use 2 iterations, meaning we're going to do it twice. All right? So first thing, before I even attempt the question, I am going to find the derivative. All right? So g of x is equal to e to the 4x minus 3 minus 4. And so I need to find the derivative, which is g prime of x. And so g prime of x will be equal to g prime of x. I differentiate this to get 4e to the 4x minus 3. That will be g prime of x. Right? And so all I need to do now is find out what is g of 1. Using Newton-Raphson formula, we know that x2 is going to be equal to x1 minus g of x1 over g prime of x1. That's Newton-Raphson formula, g prime of x1. All right, nice and easy. And this is for the first iteration. All right, this is first iteration. All right, so let's go ahead and work this out. So using the first iteration, it's going to be x1 is 1. So it's 1 minus, find out what is g of x1. G of x1 is, put in 1 right here. 4 times 1 is 4. 4 minus 3 is 1. So that's going to be e to the 1 minus 4 over g prime of x1. Put in x as 1, you're going to get 4 minus 1 is 1. And so that's 4 times e to the 1. So that's 4e. Work out what all of this is in a calculator. So you have e minus 4 divided by 4e. Then you have 1 minus the answer is 1.11. So I get 1.118, correct the 3 decimal places. And then I need the second iteration. So the second iteration will be x3. All right, so the second iteration will be x3, and so x3 will be equal to 1.118 minus g of x1. In this case, it's going to be g of 1.118 over g prime of 1.118. So we're going to work out all of this now. We're going to work it out, no issues. So we're going to work it out and get that x3 is 1.18 minus g of 1.118 Putting that now, it's going to be 4 times 1.118 minus 3. Now we have e raised to that minus 4. That's 0.357. This part works out to be 0.357 divided by g prime of 1.118. So go up here, now I'm putting x as that. So it's 4 times e raised to the 4 times 1.118 minus 3. 4 times that. Let me do that again. 4 times 1.118 minus 3 e raised to that minus 4. Why is it not giving? It's giving me math error. Let me go one more time. 4 times 1.118 minus 3 e raised to that times 4. That's 17.43. Come on, man, calculator. Why you want to fail me? 17.43. So you work this out and you're getting the next approximation is, your final answer is minus 0.357 divided by 17.43. And when you add that to 1.118, you get 1.1179, which is the same thing. 1.118. So that's the final answer. Nice and easy. 1.118. Nice, soft. That takes care of this question.